some more practice in finding the remaining ratios of the trig functions of an angle if we're given some pieces of information, are types of problems where maybe it gives me one trigonometric ratio for that angle and it tells me what quadrant the angle is in, and it wants me to find the remaining trig ratios for that angle. And this can give us a lot of help when we are working further into our applications of trig functions and we have information that gives it to us for one trig ratio, but we need to actually find the missing information from another trig ratio of that same angle. So in this, I've got two different pieces that we're going to go through. So the first one, it says that the cotangent of the angle is -5/12. So sometimes when we're first looking at these, there's so many different ways that they can ask us about the values of the trig ratios. One is if they ask the value of a trig ratio of an angle where we know the angle. And when we know the angle, then we have to ask ourselves, well, is the angle that we know a nice angle, or is the angle that we know some general angle that we don't have the actual exact trig ratio of? And we can either then go to, if we know the angle, our unit circle, or other ways that we know what those ratios are, or if we don't know the angle, then it's not a nice angle, then we could go to our calculator for an approximation. If we have the trig ratio of an unknown angle, but they tell us what the ratio is, there's a couple different things they could be asking us about that. Sometimes they ask us what the angle is if you have the trig ratio of an unknown angle and they give you the ratio and they want you to find the angle. But that's not what they're asking here. Here, they have the trig ratio of an unknown angle, but they give us the trig ratio, and they want us to find the trig ratios for the other 5 trig functions. So I don't need to go through and find the angle because there's so many connections between the trig ratios of an angle and also its placement on the xy plane. So with this, I have the cotangent of theta is -5/12. And this notation here is saying that theta is an angle that's in quadrant 4. So its terminal side is in quadrant 4. So when I draw this, I have that I have a quadrant 4 angle. So its terminal side has got to land in quadrant 4. Now, when I look at making a triangle out of this to be able to set up and be able to read the trig ratios off of it, you always go from the end of the terminal side of the trig ratio, terminal side of the trig angle in standard position, or a point that you know there, and you go to the nearest x-axis. You never go to the y-axis, always to the x-axis. Now I can look at what the ratio is, and I have to be careful about the negative sign because this is saying overall my fraction is negative. So -5 divided by 12 doesn't simplify anymore, but negative divided by positive is overall negative, and positive divided by negative is overall negative. And I don't know which numerator or denominator, which part of that fraction the negative goes with, until I think about what it has to be with where the angle is in that quadrant. So to get to the 4th quadrant, I have to go right and down to get into the 4th quadrant. So my x-coordinate has to be positive and my y-coordinate has to be negative for that angle to have its terminal side in the 4th quadrant. Now, if we recall just our trig ratios of any angle when we look at it in the xy plane, we have that the cotangent of theta is x over y. And we could also remember that if this is my theta, then my reference angle is here. With the right triangle, the cotangent of an angle is the reciprocal of the tangent of the angle. since the tangent is opposite over adjacent, the cotangent is adjacent over opposite, okay, which is the x-coordinate over the y-coordinate. So when I look at this fraction, my x-coordinate has to be positive, my y-coordinate has to be negative, the x is in the top, the y is in the bottom, so I need to think of this cotangent theta ratio they gave me as a positive 5 divided by a negative 12, because my x-coordinate has to be positive and my y-coordinate has to be negative to land in the fourth quadrant. Okay, so this is a positive 5, this is a negative 12. And then to get the hypotenuse, which I'll need in finding the other trig, many of the other trig ratios of this angle, we want to remember that the hypotenuse is, by Pythagorean theorem, the square root of the leg squared plus the other leg squared, or also r, the distance from the origin to this point, is just going to be the square root of the x-coordinate squared plus the y-coordinate squared. So 5 squared is 25. Negative 12 times negative 12 is positive 144. So I have 25 plus 144. That is the square root of 169, and the square root of 169 is 13. Just as a side note, when the ratio they give you has a component of it that's the r, r is always positive. Your minus sign will either be on the x-coordinate or the y-coordinate, or both, depending on if it's in the third quadrant, but your r is always positive. So my r is 13, and now I'm ready to read off the rest of the ratios. So we know that the sine of the angle, which is the same as with our reference angle, sine is opposite over hypotenuse, so negative 12/13. Or we could go back to the definition with the xy plane, and sine of an angle is y over r, y over r. The cosine of the angle is the adjacent over the hypotenuse. Another way of thinking of it is x over r. The tangent of the angle is the opposite over the adjacent, so negative 12 over 5, or y over x. And then we have our cosecant of theta is our reciprocal of sine of theta, so that's negative 13/12. Or we can, again, think of that as r over y. Secant of theta is the reciprocal of cosine of theta, so 13/5. And then cotangent of theta, we already know they gave that one to us. That's our negative 5/12. Okay, so here we have the remaining 5 trig ratios of given the one. So now that you've seen that example, let's go on to the next one. So here I have the sine of theta is 15/17, and my angle is in the second quadrant. So we are going to draw our second quadrant angle. We're going to bring the vertical line down to the nearest x-axis to make our triangle, so our reference angle here. Now when we look at getting to the second quadrant from the origin, you can think even how you had to do this back in your algebra classes. To get into the second quadrant, you have to go left and up. So my x-coordinate has to be negative, my y-coordinate is positive. So when I look at that and I have my sine ratio and I remember that the sine of the angle is y over r, it makes sense that my ratio is positive for the sine of the second quadrant angle, because the y is positive and the r is positive. But I need to think about it too, because when I get my x-coordinate, I have to put the right sign on it so that I get into the second quadrant for the angle. So we have now, this is your x. It's a leg that's missing this time from your right triangle. So we have that x squared plus 15 squared is equal to 17 squared from the Pythagorean theorem. So I have x squared plus 225 is equal to 289. Subtract 225 from both sides, x squared is equal to 64. Take the square root, you get x is equal to plus or minus 8. But remember, we have to take the correct value for x so that it meets the condition of where the terminal side of the angle is. We had to go left and up, so x has to be negative. So we're going to pick the negative 8 for that. Okay? And now we can just read off the trig ratios of this reference angle. And your reference angle is always the one that's being made with the terminal side of the angle and the nearest x-axis. So we have our cosine of our angle is x over r, so negative 8 over 17, which I can also think of as adjacent over hypotenuse. Then the tangent of theta I can think of as our y over x, or opposite over adjacent. Our cosecant of theta is the reciprocal of sine theta, so 17/15. Secant of theta is the reciprocal of cosine of theta, so that's 17 over negative 8. And cotangent of theta is the reciprocal of tangent of theta, so negative 8/15. So there you have a couple of examples of how to find the trig ratios of an angle if you're given the ratio for one of the trig functions and you know which quadrant the terminal side of the trig angle is in.